C++ provides unary operators for incrementing and decrementing values. Here I have a working copy of working.cpp from chapter 6 of the exercise files. And we'll go ahead and create a simple value and we'll print it out. And you see the result that we get. Now, if I take this value and I use the increment operator, and then when I print it out, you see that the value is 43. Now there's two versions of the increment operator. There's the prefix increment, like I just used, which increments the value and then returns the value. And so if I use an expression like this, the value that's returned is the new incremented value. So I can build and run, you see we have that result. If I put it after the x, then the value is returned first and then the value is incremented. So if I print two of these, you see the first one is still 42 and the second one is 43 because the increment happened after the value was taken for the return. So we'll take a look at how this works in a minute, and there's a reason to do that because actually one of them is more efficient than the other one. But first I want to talk about how this works with pointers. If instead of an integer here, I give it an array of integers, and then I'll take a pointer, we'll call this IA for consistency. And so now we have a pointer to the array, which points to the first element of the array, of course. And now I take IP, what's pointed at by IP, and I'm going to go ahead and increment it the first time here, and I'm incrementing the pointer. I can go ahead and put parentheses around this to make it more clear. And now when I print, you see the value is 1 and then the value is 2. Because I'm incrementing the pointer, and so it's pointing to the next element in the array. Now, if I do the increment before the IP, you see it'll increment first, and then the value is 2 for both times. So the pre-increment and the post-increment. And it's worth noting that you need the parentheses with the pre-increment, and you don't with the post-increment because of operator precedence, which we'll cover later in this chapter. So it's always a good idea to just use the parentheses. Now, what's interesting about this, if I print the value of the pointer itself, and I do that before it's incremented and again after it's incremented, you'll notice that the pointer increases by the size of an integer, which is 4 bytes. Because it's a strongly typed pointer, and it knows the size of what it needs to increment by, and so it's doing that. If instead this was a character array, and a character pointer. Now when I build and run, you see that it increments by just 1. And I'll do this as a post increment so you can see that it's incrementing by the size of the value. So that's how the increment operator works. Let's take a look at how it's implemented because this is going to show you why one is more efficient than the other. I'm going to go ahead and delete this working copy and I'll run clean. And I'm going to take this increment decrement.cpp and make a working copy of that. And here we have again a simple number class, and here I've implemented the increment and decrement operators. So we have pre-increment, which is the plus plus before the operand, and post-increment, which is the plus plus after the operand. And you notice that the only difference here is that the word int is inside of the post-increment operator, and that's just to distinguish it from the pre-increment operator, because otherwise we just have two pluses here and we need a way to distinguish them. And so notice the difference in how they are implemented. The pre-increment, it simply takes the value, adds 1 to it, and returns a reference to itself. The post-increment can't work that way because it actually needs to return the value before the increment. So it needs to create a temporary object. Here it creates a temporary object and it uses an assignment operator to copy that object over. So it's created a temporary object, it has done a copy operation, then it increments itself and then it returns the temporary object. And because it's a temporary object, it cannot return a reference. And so it needs to again copy that object when it's assigned to something else. So you have two copy operations and a constructor and a destructor all added to this, which don't exist in the pre-increment. And so I'm going to build and run this, and you can see that it works. There's the pre-increment, and you see that the value is incremented first, and so both of these are the same. And then if I do the post increment, you see the value is incremented second, and you see that both post increment and pre-increment are called because I actually have to call the pre-increment in order to do the increment of this object before I return the temporary object. So clearly the pre-increment is far more efficient. So the unary increment and decrement operators are very useful and very commonly used. Keep in mind that the prefix version increments before returning the value, and the postfix version increments after returning the value, and that the prefix version is far more efficient.